Greetings, fellow nerds. In this video, we're going to make glow sticks of various colors and explain a few interesting points about them. But first, I need to crush your expectations. This is much more complicated than buying a glow stick. For small amounts, this is also more expensive. Making glow sticks this way only becomes cheaper if the chemicals are bought in bulk. Once again, our primary objective is to explore the science. So let's begin. First, we start with a solvent diethyl phthalate. We can't use water because some of the chemicals don't work in water. Now we add some dye to give it color. I have here 4 different dyes, but first we're going to start with 9,10-bis-phenylethanol-anthracene. It looks orange in the solid state, but it dissolves to a green color. Let me shake it up. As you can see, it is green when dissolved. This will give us a green color for the glow stick. Now we add the key ingredient bis-2,4,6-trichlorophenol oxalate, also known as TCPO. This stuff is what makes glow sticks work and provides just the right type of chemical energy to generate light when mixed with a fluorescent dye. Now I'm adding sodium acetate as a base. This reaction works better in alkaline conditions than in acidic conditions. Sodium bicarbonate and sodium salicylate also work if you don't have sodium acetate on hand. Okay, we're ready. The final ingredient is hydrogen peroxide. This reacts with the TCPO and decomposes it, generating the chemical energy that transfers to the dye and gives it the glow. Let me get the lights. Well, look at that. It's not fully mixed, but it's already starting to react. Let me give it a shake. There we go. Nice. And that is a green glow stick. Okay, let's try a few more colors. Lights. Wait up for my camera to rebalance. Okay, let's start with a new batch of diethyl phthalates. Our next dye is Rubrene. It looks bright red in the solid state, but after mixing you can see here it gives a bright orange color, and will give a bright yellow glow. Once again we add in our TCPO. Other chemicals that can be used include bis-2,4-dinitrophenyloxalate, also known as DNPO, and bis-2,4,5-trichlorophenol-6-carbopentoxyphenoxylate, also known as CPPO. A lot of peroxalates can be used, but the ones I mentioned are the most useful. Now for the sodium acetate. In a real glow stick, all the chemicals are mixed first, but the hydrogen peroxide is kept separate in its own glass tube. When you break the tube, the peroxide mixes and starts the reaction. That's why glow sticks make that cracking sound. It's the glass tube breaking. Here we are just going to add directly. Lights? Whoa, that is really bright. It's much brighter than the green one. Let me put them side by side. The green one isn't dead, just my camera has set the contrast auto balance too low. See, when I take away the yellow one, the camera can readjust the contrast. I can tell you personally they are actually both very bright, but the yellow one is much, much brighter. Okay, let's set those aside and try another dye. First, the diethyl phthalate solvent. Now the dye we're going to use is 9,10-diphenylanthracene. It's an off-white color in the solid state, and it dissolves to give a clear solution. Now all these dyes have to be fluorescent. Non-fluorescent dyes do not work. It's the fluorescent color that the dye ultimately glows with. 9,10-diphenylanthracene is clear normally, but will actually give us a blue light. Okay, let me add the TCPO and the sodium acetate. Some of you might ask if luminol can be used. Luminol is a very different substance and works by a different reaction. While it does glow, it is much weaker and does not last as long as TCPO and similar type chemicals. Anyway, here we are with the hydrogen peroxide. Lights? Now that is a nice blue color. It actually looks closer to violet or purplish, but the camera doesn't quite pick it up perfectly. Let me get the other ones. As you can see, the yellow one with the Rubrene dye is still the brightest. Looks like the green ones separate a little. Well. A lot of people ask how long these will last, and that depends on how much of the chemicals you use and what temperature the solution is at. The amount I use here at room temperature can last several hours to a day or two. Okay, let's try our last dye. This is Rhodamine B. It's green in the solid state, but as you guessed by now, very few things I do are as they appear. When it dissolves, it gives us this deep red color, and that is also the color it will glow. Okay, let's add our TCPO and sodium acetate. Now, there's a viral video out there that says you can make Mountain Dew glow with just baking soda and hydrogen peroxide. I can give you my expert scientific opinion that it's fake, as well as all the so-called successful copies. Mountain Dew does not have the right chemicals for it. But if you don't believe me, just try it yourself. Experimentation is the core of the scientific method. Okay, enough ranting. Here we are with the hydrogen peroxide. Lights. This takes a little longer to activate than the others. And that is red. Let me get the other ones to compare. Now, rhodamine isn't actually used in glow sticks much because, as you can see, it's decaying slowly and will die out sooner than the rest. Anyway, that is how you make different colored glow sticks. Some of you will probably ask how a white glow stick is made. That's actually very simple. All you do is mix together yellow and blue. That's a nice multicolor effect. Anyway, let me give it a shake. And there you go. That is a white glow stick. I use a tiny bit too much yellow. But here is one where I got the mixture right, just so you get the idea. Now, a lot of people ask what happens if you don't use any dye at all, and if that will give you a white light anyway. The answer is no. Let me show you. I'm going to mix up a batch without the dye. Now, the reason why it doesn't work is because the chemicals don't actually release light. They release energy. This energy must then transfer into a fluorescent dye to generate light. This might sound odd, but fluorescent dyes work a little differently than normal absorption-based dyes. Normal absorption-based dyes work by absorbing particular colors, and then reflecting or passing through other colors. Now, fluorescent dyes also do this, but they can also generate light by converting light of high energy, like ultraviolet, into light of lower energy, like the visible colors you see. Normal dyes don't have this mode of operation. The TCPO and hydrogen peroxide chemicals generate chemical energy that the fluorescent dye can convert into visible light, without needing ultraviolet light. If they directly generated light, then we could see it without the dye. Okay, enough talk. The best part of science is testing our theories. Lights. I'm adding in the hydrogen peroxide now, and as you can see, nothing visible is happening. The chemical reaction is going, though. Without a fluorescent dye to convert the energy, it's just being lost as heat. Here's a comparison of the theories. I think it's pretty obvious which one has more supporting evidence. TCPO does not generate light, not even UV light. It generates energy, which must transfer into a fluorescent dye. And that's the basic science of glow sticks. Thanks for watching. Please subscribe, rate, and comment. Further information, including quantities of chemicals and where I get them, can be found in the video description.